All right, just going to give everyone a minute or so to connect to the audio. Can everyone hear me okay? Okay, awesome. Good morning, everyone. Thank you so much for taking time to join us this morning. I'm very excited to have two different companies as our guest speakers for today. They'll each have about 20 or so minutes to give you a little spiel about who they are, and then 10 minutes for questions from you guys about their product or their company and how they could potentially help you and your producers. So we have TerraForma, who is a company specializing in selling / leasing bioreactors for custom microbial products, as well as Autonomous Pivot, who has AI generative sensors for you to install on center pivots. We're going to start with TerraForma, and I'll let them introduce themselves if you guys want to take it away.
Awesome. Thanks so much, Liza. So I'm going to share my screen here and just get this presentation up and running. But my name is Miles Sorrell. I'm the CEO of TerraForma. I also have with me today Cooper Scarborough, our COO, and Lorenzo Ars, who is one of our project managers based out of Colorado. We are a company focused on soil microbiology and soil health, helping growers to create better practices in management of their fields, reducing their costs, increasing their yields, and fundamentally just growing a healthier crop. So just to dive right in, as we are at a limited time frame here. As mentioned, we exist to enhance biological functionality of soil and thereby increasing crop sustainability and farmer profitability. So for us, that effectively means sustainability through profitability. To kind of clarify that in a bit more detail, we are looking for processes and practices that are going to fundamentally create more wealth for growers as opposed to just add cost and weigh them down. So just to open up, we're going to talk about a couple of educational concepts around soil health, soil microbiology, why it is important to maintain these structures and ecosystems for a productive ecosystem and highly productive soils. The first concept that I want to touch on is succession, which is the ideology that what you see above ground in terms of the crops that grow, there is an equally reflected below ground ecosystem that is equally important in cultivating what you're seeing above. So if we're looking at something, say grasses, soybeans, corn, you're going to have a balance of bacterial and fungal biomass within that ecosystem, within the soil. That's important for maintaining the health of that crop. Whereas if we're growing something like peaches, grapes, pears, we're going to have a much more fungally dominant ecosystem that's going to support growing these larger, longer term plants. Effectively, when you're implementing a lot of typical practices that you'll see in conventional ecosystems, like tilling, fertilizing heavily, utilizing fungicides, herbicides, pesticides, we're fundamentally pushing these ecosystems towards a more simplistic state where you derive more weed pressure, you end up very bacterially dominant. And this is important because there's both this sort of biomass balance within the soil, but there's chemical reactions that are driven by those microbes within the soil that help to balance the type of nutrition that plants are receiving, as well as structure the soil and the ecosystem. So our goal is always to look at the cropping system and bring that cropping system back to balance within the soil microbiome to be able to support that crop at the proper levels of interaction. However, that's not the entire picture. Fungi and bacteria are critically important. We want to have that balance in place, but they are just that first level of interaction between the plant and the ecosystem that lives within the soil. So the plant's going to be uptaking, CO2, putting that into the roots, sending that out through exudates into the soil. That's going to attract a lot of these fungi and bacteria. They're going to help degrade organic matter, help to interact with the root system, but they're really not releasing a lot of that nutrition back to the plant. They're holding it within their biomass. So in order to get that cycling moving and create nutrition out of your natural ecosystem, we need to see upper level predators within that system as well, including protozoa, nematodes, arthropods, earthworms, a lot of these beneficials that are able to consume that bacteria and fungi, make those nutrients plant available, and increase the flow of nutrients into the plant through natural means. These organisms are also able to help with pest regulation. If you have predators in the system, you're going to be able to help kind of reduce the amount of pest and disease pressure coming into the plant, both through occlusion, chemical excretions, and generally improve physical properties of soil in terms of aeration, soil structure, and movement of water and retention of water within those systems as well through the interactions of microbes. So to touch on why diversity is important, because so far we've talked about different types of organisms. We might have 1 or 2 fungi in the soil, but why is it important to have hundreds of different fungi in the soil? This is for redundancy, which is basically to say, hey, these microbes have similar functions between them. Why do we need more than one? Well, you might have one die off, or you might have one that functions in high water conditions and another one that functions when it's drought. So if we're able to have this natural redundancy built in through a lot of different types of bacteria and fungi and predatory species, we're going to end up with a system that's always going to be able to perform functions optimally under different types of environmental conditions. We're also going to be able to utilize quorum sensing. This is an idea basically where a certain amount of compounds within the soil reach a certain point, and that changes how those microbes interact. Having more of those microbes in that system can change how that community functions as a whole. So the sum is great. The whole microbe community is greater than the sum of its parts, than each individual microbe that we're looking at. So you can actually get quite a lot more if you have that broader spectrum of microbes. We also want to see higher resistivity. So, you look at anywhere in the Midwest in Colorado, we have this huge shift where we're getting really weird weather all the time, right? Droughts, too much rain, it's all over the place. And those types of environmental stresses are easier to resist if you have a broader diversity of microbes within the system. They're more easily able to recover, re-inoculate those soils, as well as to resist these different changes. And then competition is very important. Being able to occupy different niches within the soil, different spaces that different microbes are going to do better is really important for competing with different disease-causing organisms and different pests that might get into the soil system. So being able to have that broad diversity is incredibly important for the functionality of the soil and building all of those different functions into it. Just this diagram on the right is kind of just illustrating that flow of information through organic matter and the benefit of biology through the system, pardon me. So you'll see, as you're adding and cropping system, the system's going to have root exudates, litter quality, all these things kind of funneling in towards building out your microbiome. And then that microbiome is actually going to feed back into control of pests and diseases, as well as into the component of soil chemical and physical fertility. And plant production. So if we remove this biological component, if we're not putting attention into catering to it and building it up over time, we are losing a huge portion of a contributing factor towards soil productivity within the system as well, and control of pests and diseases. Looking at the nitrogen cycle, because this is the cycle everybody really likes to focus in on, this is fundamentally a microbial driven system, right? It's all the microbes that are doing all of this work, that are transforming the nitrogen that's put into the soil, making it available, but they're also responsible for the nitrogen that you lose within that system as well. So I just want to touch on a couple of these different pathways, denitrification being one of them, where you lose nitrogen because the microbes are off-gassing that nitrogen. This is typically happening more in anaerobic conditions, so heavy water in the soil, heavy compaction levels, not really having access to air. So it's structural for a piece, but adding synthetic nitrogen can actually increase the amount of volatilization that you see. The excess nitrogen begins to off-gas more rapidly. Nitrification is another process where you're more susceptible to loss of nitrogen. This is taking ammonium and turning it to nitrate. Nitrate is very susceptible to getting washed out of soils. It's not very secure within that system, and it tends to grow more annual weeds. So you're going to have higher weed pressure, you're going to have higher loss of all that nitrogen going into the soil. And of course, putting more nitrogen in is going to push that system towards producing more nitrification typically. Ammonification is the opposite of that. We want to see more ammonium in the soil. It's more secure, it's less likely to leach, it's going to last in the soil for a longer period of time. So if we can encourage more biological function of ammonification, we're going to end up with a more secure flow of nitrogen throughout the season. And then, of course, there's nitrogen fixation, which is bacteria taking atmospheric nitrogen, incorporating it into the soil. It's a way to get kind of an external nitrogen source without having, from within that closed soil loop, as a lot of people like to view it. And adding external nitrogen can actually hinder the performance of these types of organisms. You're not going to fix 160 pounds an acre with a nitrogen fixing bacteria, but they do serve a critical function and role over time. And so the idea here when we're looking at a nitrogen-based synthetic kind of conventional system is we want to maximize the use of all of the synthetic nitrogen that comes into a system. And microbes can help regulate that by either helping to convert it into a form that's more secure in the soil or by incorporating some of that nitrogen into the actual biomass. So it'll hold the nitrogen in the system for a greater period of time. If you look at this diagram on the right, this is just a quick indication of sort of how nitrogen moves through the system. The main highlights that I want to look at here is as you're putting synthetic nitrogen in, you're going to be producing a lot of above ground nitrogen in the leaves, in the plant. And as those plants get harvested, a lot of that nitrogen still is in the litter. So in the leaves, the stalks, everything that's left on the field still holds a lot of that nitrogen that you're adding to the plant. So as much as possible, it's always a good idea to try to conserve your litter, keep it within the system and not immediately volatilize it, expose it, and lose it over a short period of time. And that can help to build up soil nitrogen over a longer period. But as you do add those synthetics in, you do see a drop off in the type of microbial biomass. You see a lot more leaching, a lot more volatilization, and a lot more nitrification through that system as well. So when we look at pest and disease control, because this tends to be one of those overarching difficult things to deal with, predation, occlusion, and biocontrols are sort of these natural mechanisms through which the plant, the microbiome, and the soil all interact to be able to help control pathogens and diseases. Effectively, predation is just consumption of these microbes. The better we have, or the more diverse and active predators we have within a system, the better we're going to be able to regulate those pests. As well as occlusion, which is both a mixture of plant defenses and microbial competition to limit those pathogens from having access to the roots and infecting the plants. And then biocontrols are more targeted, specific ways to use a microbe that targets and kills fungi or a pest that can be incorporated into this type of program. So looking at this idea of biological functionality, because this is something that TerraForma has developed over time, this is the concept that if we can increase the biological functionality, we can reduce input requirements and increase output. And biological functionality is basically the capacity of soil to produce nutrients, suppress disease, and increase environmental tolerance over time. And as we're able to build that up through increasing organic matter, through higher diversity and functionality of that soil, we can start to pull off and reduce synthetic and external inputs from other sources. So just give a little bit of background on where we've worked in the past and how we've implemented this system and these types of systems. We have worked all over the world in different types of crops, different types of soils. And the main focus here is just that these types of regenerative practices where we are implementing increases in organic matter, putting microbes back in the soil, they work all over the world with all sorts of different crops. So Colorado, for instance, is no different. We have projects here as well. And you're able to see these benefits no matter where you are. So one of the main targets that we as TerraForma drive home is to make data-driven decisions. We utilize different types of techniques, including genetic analysis of soils mixed with biomass analysis and chemical and physical factors to be able to determine which pieces of the microbiome are missing from your soil. And this is critically important, whether it's our analytics or another one, having the data to be able to really understand what's happening is critical for deriving decision making and what changes need to be made and what types of practices need to be implemented to rebuild a potentially broken ecosystem. This is a slightly larger picture. If anybody's curious about this, we're happy to share a PDF of this, but we're a little short on time. So I don't want to dive too much into the analytics right now. This is our TerraPod. This is our bioreactor. It's a system where we're able to cultivate local microorganisms for extraction into liquid and inoculation into fields. It is a composting driven system, so we're doing a very targeted, precise composting process. Right now we're producing that out of Longmont and Boulder. And we're able to cater that recipe to the deficiencies that we see in the analysis. So if we see that we don't have enough fungal biomass, we're going to design a feedstock that goes into the TerraPod that's very targeted to growing out fungal biomass at high diversity. The main benefit to this type of system is we're able to put it on site and cultivate all those organisms on the farm and use local inoculum to diversify the end product. So everything's fully localized to your environment. It's all alive and active when it's going out into the fields, and it's never put into a dormant state like a lot of other products. As much as possible, it's always important to try to find these types of systems where you can get a high quality biological amendment into the fields to be able to re-inoculate, stimulate that regrowth, and associate with the plants as soon as you can within a growing cycle. And then finally, sustainable management practices go hand in hand with these types of biological methodologies. Biology is not a silver bullet to fix everything. It's one piece of a puzzle. And doing things like biocomposting or composting generally to increase organic matter, add some organic nutrition, looking into processes like cover planting to build up organic matter over time, diversify the feedstock that goes into that field. These are all processes that will help to encourage better biological functionality within the soil and help to reduce synthetic external outputs and stabilize your soil system. So really, we want to see these practices come together where we're making some of these changes in terms of management practices as well as products that are coming into that soil. And then we have a little bit of time left over just to touch briefly on a couple of case studies and fields that we've looked at where we've implemented some of these practices. And I'm sure you guys will be able to implement some of these practices in your own farms. But we tend to see enhanced plant health. So better root mass, reduce root feeding nematode populations, and better nutrient cycling, lower input costs as you're switching off of synthetics in favor of utilizing your natural microbiome, and also increase revenues as you're able to reduce your cost structure and increase your yields. Just to start, this is a soybean study that we ran, one in Brazil and one in Iowa, where we were able to get around a 5 to 30% yield increase over a control with just using a extract into the soil from the TerraPod. These projects weren't utilizing other implementation at this time. It was just a controlled study, but we were able to see a pretty large profit increase per acre and per hectare based off of these implementations. So you can see a very quick turnaround with a lot of these different cropping cycles, where even just one application in the early part of the season can do quite a lot for the growth of the plant, especially in soils that are in desperate need of rebalancing within their microbiome and ecosystem. We've also worked in bananas in Ecuador. This is a little bit less relevant to Colorado, but it does demonstrate the value of building out a composting system within your operation or utilizing compost within the operation. We were able to reduce the fertilizer cost substantially here while increasing yields after implementing a high quality compost as well as biological extract implementation. You can see on the left here, this is a banana that was not treated. It's got SOP standard protocol. On the right, we implemented biology, and we were able to take genetic analysis and see on the right that we had more hormones being produced from the soil. So the bacteria that we had inoculated were producing auxins, gibberellins, things that cause the roots to grow, both axillary and fine roots. This led to a pretty big saving in fertilizer per hectare in this case in South America, and also increased revenue, which made them quite a lot of money for their operation. And then this is just a photo of kind of their composting layout. We help them set this all up. You don't always need a roof. This is a pretty advanced operation, but we're producing about 3,000 tons for them a year. And that's gone a really long way to help them rebuild their soil structure, get more organic matter, and also replace some other inputs that they were working with at the same time. And then finally, we have a grape study out of Peru. And we were able to take this farm from fully conventional to fully organic and get a 30% yield increase over 3 years over their historical averages. We were able to do this through a combination of practices and microbiology coming into the system. It's a bit hard to see here, but underneath the canopy, you can see some of the grapes here. It's not entirely closed out. And then next year around this time, after 1 year of treatment, we were at this stage where we were able to close out the canopy entirely, have much higher density of the grape population. So we had a really good result with managing the system and increasing the productivity. They also were running a compost facility prior to us showing up. And so we helped them kind of refine and fine tune this. There is a gradient to quality of compost. You definitely want to be using something that's well produced, well aerated, maintaining high quality nutrition, isn't putting out, a lot of volatile toxic compounds from the process of production. And then we produced about 5,000 tons a year for them, working with their team. And then we also worked with some of these practices that are going to be slightly different than what you'd see in Colorado for most crops. However, they'd be applicable in the same functionality. If you look underneath the vines here, you'll see a lot of weed pressure. So we started exploring with the grower ways to control that alternatively to herbicide. And we started using things like mulch that you'll see here on the right, where we started putting these thick layers of different organic material. And it worked to suppress the weeds, but we wanted to evolve that into a state where it was a little bit easier to manage and had more benefit and lower cost. So we started planting sun hemp, which is a nitrogen fixing plant underneath the canopy. And that worked very well for weed control, as well as increasing the nitrogen that went to the soil and the organic matter. And we actually ended up planting about 3 different cover plants within the system for different reasons that allowed us to help the grower completely eliminate herbicide, as well as massively reduce the synthetic inputs coming into the operation. At the end of the process, we ended up with something that was very, maximized in terms of fixing photosynthetic potential, increasing the amount of planted space so there are less gaps. And you'll see there's sweet potato planted in the middle of these rows as well. So it turned into a very regenerative practice, but at the end of the day, reduced cost and increased output through all of these practices, while increasing soil health, and the overall environmental impact from this operation was massive, drastically reduced. So yeah, I think we got through that in decent time with some time to spare for questions if we have any questions here.
Awesome. Thanks so much for that presentation, Miles. Yeah, if anyone in the audience has questions, please feel free to unmute and ask, or put it in the chat. We'll have like 5 minutes or so for questions before we have our next speaker talk.
Does your inoculant, does this survive drought?
Yeah, so part of the process of inoculating locally with microbes is we're trying to select a really broad range of potential inoculant. When we put something out there that has like 500, 600 plus species in it, we don't expect everything to live, but the organisms that are most adapted to that environment are going to best perform. So it will survive drought. Obviously, when you look at like application protocol, as much as possible, we do want to get the inoculum into the root zone, like underneath the surface of the soil. We don't necessarily want to go out and spray in the middle of the day on top of the surface of the soil when it's just going to kind of bake on the surface. But they will survive drought, and they will be able to function through drought as well. And they can help with building structure to retain more water within the system as well.
Thanks for the great video, or thanks for the great presentation. It was nice to see all the scientific data on the screen based on how you guys are using it. Curious if we're working with folks that are interested in having you guys come out and check out their production and property. What's the best way to get them? Is it to give them this contact on this screen, or direct them to the website? How do they get your product?
Definitely. You can either contact us on screen here, or you can go through the website. The website's great to reach us. We usually respond within a day or two to any sort of like website contact. So I would recommend going to the website, but you can also reach me directly on this phone number as well.
Okay, and is there a like standard consulting cost for you guys to work with somebody to see if it's a good fit? What can I give somebody as a warning, like what it's going to cost for you to come out and check it out?
Yeah, so I mean, just to connect, we're not going to charge anything to talk with somebody and kind of understand their situation and if we're going to be a good fit with them. So if somebody wants to reach out and talk and see if we would be a good fit, we're happy to do that free of charge, and we'll kind of talk a bit about their situation and how they might be able to fix that. We do tend to work with larger, like mid to large size growers. The TerraPod's spec'd out to service approximately 500 acres of corn and soy. And then smaller parcels of like peaches would be closer to like 100 acres, 50 acres. So it's scaled up pretty big. So a lot of smaller growers will struggle a little bit to leverage that unless we can kind of position a TerraPod in an area where multiple growers can share it on a smaller scale. Consultative services, we usually charge about like $250 an hour, or like I believe it's $1,500 a day on site. But again, if we're based in Colorado, we're not going to be doing full days and stuff like that. And again, we're happy to chat for 30 minutes to an hour just to understand where things are at and give some light guidance. And, if we end up not being a good fit, that's okay. We can still try to share a little bit of information.
Great. Thanks. That's super helpful.
Yeah.
So we had a question in the chat that I think Cooper answered. Someone wanted to know what the time interval from ordering your composter, the TerraPod, to delivery. And Cooper said it would be about 8 weeks after it arrives and is installed for the first solution to be available. So I guess sort of in that same vein, could you kind of, if someone was interested, go through what that whole process looks like? Like first it's a consultation, then it's like a site visit, etc. Like what does that process look like?
Yeah, Cooper, do you want to run through that?
Sure. Yeah. Good morning or good afternoon, everyone. So the process for us would look like first is an assessment, and we would have that conversation with you to understand your practices, your really your crop, and some of your objectives. Then, if the pteropod becomes of interest, that would be released for fabrication and procured to your site. We would then come out and install it on site, show you how it works, and then once it is installed and the feedstock has been pretty much planted within the pteropod, then the incubation begins, right? And so that's when we're growing out the locally sourced microorganisms. This would take about 8 weeks for preparation. So just keeping those timeframes in mind, we can talk about schedule and what things look like for your farm. But as Miles said, please do reach out if you have more questions and would like to understand our process, either through our website or the info@terraformasoil.com is a great way to get more information.
All right. Any other pressing questions before we move to our next speaker, just to keep on schedule with the time? If not, Daniel, I think we're ready for your presentation.
I have a real quick question or thought. Is there a potential, so we have some of our entities or conservation districts, they have equipment grants, equipment grant funds, and we would allow them to use those funds to work with your team. Could they say get one of the pods or a couple of them and then use it to make extract for multiple producers?
Definitely. Yeah.
Okay.
We don't restrict rights to it. If you have the system, you can go ahead and use it how you want. It does have a 2-month cycle, like Cooper mentioned. Once it gets going and everything's set up on site, that does mean that you can produce 6 months of the year. You get 6 applications a year kind of maxed out, and each harvest basically is about, or each cycle of 2 months gets you about 10,000 liters. So it's a pretty high, we do a very high inoculation rate, really low cost per liter, or cost per gallon, with the idea that we want to get maximal impact. But yeah, we can set up things like that. We've talked with NGOs in the past as well about setting up the type of shared structure, and it's something that can definitely work.
Great, thank you.
Okay, great. Thank you so much for that presentation. And yes, we will send a follow-up email with everyone's contact information for TerraForma and Autonomous Pivot. So if you have any questions you think of later, this is not your last opportunity, but let's switch over to Daniel Jenkins from Autonomous Pivot. Thank you.
Thanks, Liza.
Great.
Thanks, everybody.
Thank you for the opportunity. Yeah. Miles, great presentation. Very exciting tech that you guys are pioneering there. Let me pull up my presentation here. So Autonomous Pivot essentially is a complete and integrated on-pivot solution of integrated multiple sensors and cameras. Here you can see the system configured in a standard field. Our goal is to convert the pivot from just the means of application to be the primary method for data collection within the field. There are hundreds of thousands of pivots across the US. There's nearly 10,000 pivots in the state of Colorado. No matter what sort of controller or technology you're using to empower that device, it's still not providing you agronomic data from the field. It might tell you how many wetted hours, you might be able to turn it off and on, but it's not going to tell you about the crop growing underneath it or the soil moisture that's available to that crop. And so we really pioneered the question of how can we equip the pivot to provide more information and let it be the primary tool. So we do that, as I said, by deploying a complete set of mobile sensors. What we've got here is our ground penetrating radar. This provides soil moisture feedback in real time from all around the field. We also integrate a tipping rain bucket that allows us to measure specifically recorded in-field rainfall values. As you guys know, the precipitation is becoming increasingly more variable. Even fields that are adjacent one to the other, we see a difference in rainfall values. So the importance of having sensors in the field, not just using remote sensing or local mesonet, but actually recording what's happening in the field is really the essence of our system. And then we also have our mobile crop health sensor. So this is an integrated camera unit with GPS and multiple lenses that provides imagery, as I said, every 30 minutes from around the field. So how did we get here? Our co-founders started with a very prominent static soil moisture company, soil moisture sensor company, sorry. And they essentially had the challenge of how do we make a more accurate irrigation recommendation from one point in the field. And so they worked to incorporate different soil maps and satellite imagery and find ways to extrapolate that data. At the end of the day, they realized if we could get 2 points or ideally 3 points in the field, then we can really start to triangulate soil moisture, understand the variability within the field, and make a much more accurate recommendation. So our innovation is this mobile, non-invasive ground penetrating radar. It goes on this 18-foot boom, as you can see. It sits out in front of the irrigated footprint. So we're reading dry soil ahead of the irrigation application, which most of you all would know. If you're going to go out and check for soil moisture, that's exactly where you should be going to check to see if there's sufficient moisture to shut the pivot off or if you need to continue to irrigate. Another benefit of our system is the fact that it's non-invasive. This allows us to read soil that hasn't been affected. It hasn't been drilled or slurried or dug in. If you'll notice, here's the brace for the pivot tower, and here's the first V-jack. So while it may look like it's in front of the wheel track, it's actually a good 15 feet in. So again, this allows us to read undisrupted soil ahead of the irrigated footprint. And we really start to see the value in multiple readings as this takes readings every 30 minutes during the pivot's revolution. I'll be happy to answer more questions about ground penetrating radar and what that does. But essentially, this provides us feedback as we're calculating a water balance for each slice around the field. In order to get sensor data from the pivot to your phone, we needed a wireless gateway. And so our camera unit essentially fulfills that role. We figured if we have to have a computer and a wireless gateway, we might as well have some imagery as well. So you can see here we have 2 cameras. This one provides a narrow camera, which allows us to see sub-millimeter features on the crop. The second camera is a wide angle image, and that allows us to see essentially a bird's eye view, if you will, as if you were sitting up on top of the pivot. These are incredibly useful as we can detect diseases and weed pressure. We can give alerts for anomalies, for irregular emergence or stand counts. And we're even looking to integrate those for some yield prediction modeling. But ultimately, our goal with this unit is to be able to provide a permanent set of eyes in the field. I know lots of good farmers across the Midwest and several in Colorado, and I know that they're out checking their fields constantly, that they're always paying attention. But the simple fact remains that nobody is in their field as much as their pivot is. And the fact that it's not providing agronomic data is really an underutilized tool on the farm. And so our system essentially enables that pivot to become its own reporter, if you will, having a permanent set of eyes that's able to give feedback about all of these different metrics. Ultimately, we're collecting all this information to issue an actionable irrigation recommendation. The whole method of how we collect data and import this is so that we can leverage the variability within the field and help growers save irrigation passes. So all the data that's collected, we essentially implement the core robotic cycle of sensing, analyzing, and acting. The GPR provides a soil moisture feedback. It goes through the camera unit, where we then upload it to the cloud. We supplement with third-party weather data, including our own tipping rain bucket on location. And we also use third-party aerial imagery, so fixed-wing aerial imagery from Ceres, to provide thermal and NDVI images for the field. All that information goes up into the cloud and is output through, our AI agronomist, if you will, as an actionable irrigation prescription, which can then be uploaded into the irrigation controller. So those are essentially the sensors that we use, and this is how we collect the data and how we analyze it. What does the grower get as a result? So we offer both a web and a cellular-based mobile platform, be accessed through phone, tablet, or laptop. What you're going to see here mainly is our field imagery. We split each field into 45-degree wedges, and we calculate values for soil moisture and applied irrigation in each one of those independently. So here you can see applied irrigation events in green. You can see recorded rainfall events in blue. We're also calculating evapotranspiration based on our imagery, and we show that value here in red. The bottom, you have the time scale with dates. We're also tagging growth stages and transitions as the crop develops. And then we're issuing you soil moisture levels for that slice, as well as a management allowed depletion line or a trigger line here in purple. So very simple, straightforward platform that gives growers access to the fine details of irrigation water management without lots of graffiti, if you will. Here you see our independent values for GPR. So here you can see some of those rainfall events. You can see the response in drying and wetting. Moving on to our imagery. In each field, we were able to tag not only the growth stage and the relative location, but you can also extract the GPS coordinates for each one of these images for precision scouting. So if something's detected either by our AI engine or one of our agronomists and the grower receives an alert, you're then able to go out to that specific location in the field for precision scouting. So this is, as you can see, a time and date stamp signature on each image, just before 5, just before 5:30, just before 6 p.m. The system takes a reading every 30 minutes while the pivot's irrigating, and it takes a reading every 3 hours while the pivot's static. And so ultimately our goal here is to provide abundant, reliable agronomic data from all around the field. This would be our wide angle image. And as Miles had mentioned, the importance of litter or debris in the field. You can see here that we're able to use these images not only to detect row closure, to detect emergence, but we're also able to fine tune and adjust evapotranspiration values based on exposed soil. And so having an on-sensor device that gives us insight about the conditions of the field, and then able to really fine tune the data that's being collected and presented is a distinct advantage of our system. Like I said, we also integrate third-party aerial imagery. So here you can see both NDVI and thermal images. Our system really takes the role of a scout or an irrigation engineer and has tried to create that as a robotic platform. So what sort of sensors, what sort of device could we create that's going to provide the grower with all the fine details that they need in order to maximize their efficiency and ultimately improve their overall effectiveness in operation? So I like to think about the multiple levels that we read the field and through the multiple sensors. So the ground penetrating radar allows us to see into the soil from all around the field. The cameras allow us to see sub-millimeter features on the crop, as well as a bird's eye view. And then the aerial imagery essentially provides us with full field vision twice a season to make sure that there's not some more pervasive issue that we're missing happening in the field. So again, with our water balance, we're displaying available soil moisture, recorded applied irrigation, recorded precipitation and growth stage, as well as evapotranspiration rates. And then these are our recommendations. So you can see here, each slice may have a different value. And as we just start to detect more variability from around the field, you'll be able to see more variability in the irrigation recommendation that we issue. So ultimately, our goal is to provide a tool that helps farmers save time and resources, that allows them to stay on top of their operation and quickly manage all the fine details at a glance. And I can say here that the proof is in the pudding. We've had 3 years of commercial growth in Colorado. We have dozens of fields that we monitor in the northeastern part of the state, in the San Luis Valley, and outside of Fort Collins. And we're excited to work with the Kansas Department of Agriculture, with the various conservation districts, to provide your growers with access to our tool that's going to help them save time and water. So I went a little bit quick there, but I figured I'm much better interactively than just doing the presentation. So if anyone has any questions.
Thank you, Daniel. Yeah,
Yep.
if people have questions, please feel free to unmute and ask or pop it in the chat.
What's the radius of the ground penetrating radar?
Yeah, so this is why I do it, because people ask good questions. So essentially, the ground penetrating radar penetrates up to 18 inches, and it allows us to read essentially a cubic meter of soil every 30 minutes. It's not roving back and forth on the tower. It is in a fixed static location on the pivot itself. Like I said, we do that strategically at the end of the second to last tower. And that allows us to read the largest circumference within the field without getting deviations due to edge effect or things of that nature. And so we're working on GPS-based triggers where we would be taking the same reading of the same soil every time. But it is a trade-off compared to a static probe, where static probe is going to show you one location, and you may see multiple depths, and you may see infiltration rates. What we're going to show you is essentially trends of soil moisture progression throughout the season, and you're going to see that both over time and around the field. So just a more holistic approach to managing soil, not just in one location, but in all your acres. So. I hope that answered your question.
It did.
Okay.
Any other questions for Daniel? If not, I've got a question. Is it like one sensor, one pivot? So like if a producer has multiple fields, they just install one per pivot, or?
Yeah, so we do typically, it's always a cost benefit analysis. So we keep it with one sensor per pivot, or I should say rather one system per pivot. We do have a few machines that have multiple systems on them for research purposes. But ultimately, our goal is to provide a cost-effective tool that's going to maximize the amount of data, usable data, that's coming from the field. And so instead of littering them up and down the pivot. We strategically put it there at the end. 40% of your total acreage is going to come under your last 2 spans. So if you're going to have an irrigation issue, typically they manifest at the end of the pivot. And if they do, they're going to have the largest negative crop impact because it's going to be a good portion of the field. So what we try and do is provide a tool that growers can use to manage and monitor not only irrigation, but also crop health within the field. Now, I can tell you, we have a lot of smart and capable growers. They'll have a section and they'll put a system on one. And if the soil types are fairly uniform, the irrigation capacity, the well capacity is similar, you'll see a lot of them using that one system to manage a few other adjacent fields. We also have the ability to just the benefit for remote monitoring with growers who've got 30 or 40 miles between pivots. To have that permanent presence out there in the field can certainly alleviate some burden, some travel time, some fuel, and give them more time at home. But to be able to put a system in their easternmost and westernmost, or northernmost and southernmost, so that they can start to see the variability of rain events as they come across the landscape. So, we start to ask the question of how do we irrigate efficiently, or how do we save water? What does that really mean? Save irrigation water. The crop needs a certain amount to grow, and we have to be able to apply it. We're all trying to do this to make money, but how do we make sure that we're doing that efficiently and effectively? And so what we do is we take into consideration all the fine details and give the growers all that information so that they can be confident that the irrigation that they apply is the irrigation that the crop needs.
Right. Awesome.
Yep.
Any other questions for Daniel? If not, any other questions for TerraForma? Otherwise, we'll end our meeting here shortly. Like I said, we'll send a follow-up email out to everyone with TerraForma and Autonomous Pivot's contact information, so you can share with your producers if you think they might be interested, or you can follow up with them later if you think of any other questions that you want to ask them. As a reminder, next Monday, April 1st, we will not have our Monday info session at this time. It's not an April Fool's joke, so don't come. And then the week after, April 8th, we have a different webinar with 2 other guest speakers on specialty soil testing. It'll be the ground up and cure soil. So also please join us for that. And yeah, unless anyone else has any pressing questions for either TerraForma or Autonomous Pivot, or for us, we'll call the meeting here. Thank you so much for coming and attending.
And a big virtual round of applause for our speakers. Thank you, guys.
Yes, thank you so much for coming and speaking.
Right on.
Thank you.
Thanks.
Thanks for having us. Yeah.
See you in a couple weeks.
Thank you all. Have a great day.
Yep.
Cheers. Ciao, ciao.